Hey, hello, how are you? We're going to do the Chapter 10 study guide, and I'm going to go over every question, maybe some potential pitfalls, and hopefully we'll be better prepared to take our test tomorrow. So number one, identify the base and the height of each triangle. So for this first one, remember that a base has to be part of the triangle and the height doesn't necessarily. It might actually be easier to find the height first. I've been noticing, because if you look around, the only thing that looks like a height is possibly RU, because it goes from one of the points to the triangle down flush at a right angle with another side. So if the height is RU, then the base must be the part of the triangle that's flush with, which is ST. It's not UT because this is like an imaginary line, but it is ST. The second one, the height is clearly CD. So that means the base is the whole thing. Not, I saw someone put DB. It is AB. On this one, find the area of each triangle, where the area of a triangle is 1/2 base times height. So the base here is 20 and the height is 15. Base of 20, height of 15. So we say 1/2 times 20 times 15 is 10 times 15, or 150 centimeters squared. Number 4, we have a bunch more numbers and they're all there to trick you, but trust your gut. The height given is this one over here. So the height is 8.4, and the base, if that's the height, go opposite down here, is 9. So this is 1/2 9 times 8.4, which is 4.5 times 8.4, which is 37.8. It's 37.8 meters squared. Number 5, the area of each trapezoid. Find the area of each trapezoid. So the area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. And so we have all this information. Remember, base 1 is generally the smaller one. Base 1 is equal to 15. Base 2 is the parallel side of that, so that's going to be 20 times the height, which is 12. 13 is to throw you off. The height, it cannot be the height. It cannot be the side of the side of the trapezoid. It has to be the line that is perpendicular to the bases, both bases. So we know that the area is equal to 1/2 base 1, which is 15, plus base 2, which is 20, times 12. So this is equal to 1/2 times 35 times 12, which is equal to 35 times 6. I used the half on the even number, which makes it a little easier for me. So half times 6, 35 times 6 is equal to 210, and that's inches squared. On this one, we know base 1 is equal to the small one, that's 4. Base 2 is the larger one, which is 18, and the height is 11. So this will become 1/2 4 plus 18 times 11, which is 1/2 times 22 times 11. Half of 22 is 11, so this becomes 11 times 11, or 11 squared, which is 121 centimeters squared. Number 7. So this 26 down here is there to throw you off. It's there to throw you off. It looks like the base because it's on the bottom. Well, before I begin, remember area of a parallelogram is equal to base times height. So this looks like the base of this parallelogram, but the problem is it's also including this fake free space here. That's not part of the line. The line is from here to here, which is what this top value shows. So the base is actually 20, and the height is 18. So when we do 20 times 18, 2 times 18 would be 36, so it's 36 with a 0. So it's 360 inches squared. This one, the base is 14, and the height is not 25 because that's not a right angle, guys. This is the right angle. That would be 23. So base times height would be 14 times 23. 14 times 23, which is 322 feet squared. On the back, the area of the regular pentagon is 180 square feet. So this whole thing is equal to 180 square feet. We want to find the area of this little bitty region right here. So the first thing I'm going to do is I want to find the area of one of these triangles because it seems to be split up into regular size of those triangles. So I'm going to say 180 divided by 5, which is 36. And then that's one triangle. The shaded region is half of that, so 36 divided by 2, which is 18. So the final answer is 18 square feet. This one we need to remember our trapezoid equation. Remember that area is equal to 1/2 base 1 plus base 2 times the height. So the area of the trapezoid, PQRS, is 180 square feet. So area of this is equal to 108. Find the height. So we don't know the height. I'm going to just leave that blank. We do know that base 1 is the small one. That's 10. And base 2 is the big one, 17. So we can plug these values in for that and then solve from there. So area is 108 equal to 1/2 10 plus 17 times the height. So 108 is equal to 1/2 times 27 times the height. 108 is equal to 13.5 times the height. And then I'm just going to divide both sides by 13.5. Divide by 13.5. I get the height is equal to, those cancel out, 108 divided by 13.5 is actually 8. So the height is 8 centimeters. Number 11 is the first real tricky one. Students kind of look at it and they don't know where to begin. And you won't figure it out until you remember, so the figure EFGH is a parallelogram. That means opposite sides are equal. So if this side is 9, the opposite side over here is 9. And once you know that, everything else is good. And so what we're trying to do is we're trying to find the length of AB, which is not on here. That should say EG, FG. We're trying to find the length of FG, this length right here. So the way we're going to do that, we're going to say, okay, so I want to find just anything. I have a base of this triangle and I have the height, so let's go start there. So the base and the height. So that is 1/2 9 times 12, which is 9 times 6, which means this triangle EHG is equal to 54 inches squared. So that's the triangle, and since this is a parallelogram and EG cuts it in half, this triangle right here is the same size. So You can solve for the rest one of two ways. You can use the fact that it's a parallelogram and you know the height, or you can use the fact that it's a triangle. So let's do parallelogram first. Since this is the same size as this, the whole area of the parallelogram is 108. So 108 is equal to base times height. We don't know base. Base is FG. That's what we're looking for. But we do know the height is 8. So 8 times base, divide by 8, divide by 8, cancels out, you get the base is equal to 13.5 inches. So that's one way to do it. The other way would be to do 54 is equal to this triangle right here. 54 is equal to 1/2 base times the height. So I'll say 8, and you're looking for base. So 54 is equal to 4 times the base, divide by 4, divide by 4. You get the same answer. B is equal to 13.5 inches. And that's trickier. A lot of students are going to leave off that 1/2. But which it's whatever one you see, just make sure when you're solving these that you write the whole equation down and don't try to work it in your head. That's why we always encourage you to show your work. Alright, let's go to the back of this. Figure BCDE is a trapezoid. BCDE is a trapezoid. The area of triangle BFE, this triangle in the middle, is 150 square feet. Find the total area of the trapezoid. So the first thing the only thing we know is we know this is 150, and we know some bases of the trapezoid. But nobody's given us the height, so we actually have to solve for that. Thankfully, the height of the trapezoid is the same as the height of the triangle, so that's where we're going to start. We're going to say, okay, so this triangle is 150, and 150 is equal to 1/2 base, which is 30, times the height. So 150 is equal to 15 times the height, divide by 15, divide by 15. You get the height is equal to 10, and that's 10 feet. But that's not it. You're not done. That's great, but you need to find the total area of the trapezoid. So now you have the h is 10. H is equal to 10, but you also need base 1, which is the small base, and base 2, which is the larger base, 50. So the area of the trapezoid is 1/2 times 30 plus 50, the two bases, times the height, 10. 1/2 times 80 times 10, which is 40 times 10, which is 400 feet squared. This one is also tricky. So Mr. H drew a regular octagon with side lengths of 8 centimeters, divided it into two identical trapezoids, trapezoid 1, trapezoid 2, and a rectangle. He measured the height of one of the trapezoids, that's this right here, that's 5 centimeters, and the width of the rectangle, which is this right here, to be 18 centimeters. Find the area of the octagon. Now this is another one where students struggle to start. And the reason they struggle to start is because they don't realize that this 8 is everywhere. It's 8 all the way around. And once you realize that, everything else kind of clicks, hopefully. So what we're going to do, we're going to find the area of this rectangle, this trapezoid, and that trapezoid. And we're going to add it all together. So the rectangle is equal to base times height, which is equal to 8 times 18, which is 144, and it's 144 centimeters squared. The trapezoid is 1/2 base 1 plus base 2 times the height. So that's going to be 1/2 base 1 is right here, that's 8, plus 18. This whole length is 18, remember? So that's base 2, 18 times the height, which is 5. So this is 1/2 times 26 times 5, which is 13 times 5. That's half of 26, which is 65 centimeters squared. So now what we do is we want to add everything together. Remember, this is 65, this is 144, and this is 65. So we have to add all three shapes together. 65 plus 65 is 130 plus 144, which is 274 centimeters squared. Number 14, label the base and height of the parallelogram. Interesting thing about this is you could pick anything for the base. You could pick YX, you could pick VZ, you could pick ZY, XV. It doesn't matter as long as it's a side of the parallelogram. So let's pick one. The most conventional one would be ZY. And if that's the base, now you need to find a height. There could be a lot of different heights. What I do is I pick one of the top ones, so either that one or this one. Remember, this is where we've done the ruler, go from the point down, make sure it's a right angle. So it doesn't matter, and you just need to label this. So I'm going to label that A. If you wanted to, you could label it B. It doesn't matter, just don't label it V, X, Y, or Z. So if we call that A, the height would be VA, the height of Virginia. So this one, label the base and the height of the trapezoid with B1, B2, and H. So B1 and B2 are going to be the two parallel sides. These two sides are not parallel, so it has to be MN and PO. So the B1 is usually the smaller one, B1, and B2 is usually the larger one. Now, the height, we don't have a height. It's not the side. Those are right angles, so we have to make our own. So feel free to use a ruler. You could, as long as you do it well, you don't necessarily have to. That was when we were really getting to learn it. But so I'm going to call that my height. That's not the only place you could put a height. You could put a height, I'll do it with a pencil. You could have put a height right here. You could have put a height right there. You could have put a height over here. It doesn't matter. But as long as it is a right angle with both bases. All right, number 16. Mr. Lewis, that's me, loves okra because it tastes good. It's in the shape of a pentagon. Sometimes they're not, but a lot of times they are. He recently grew the world's largest okra. Not true. The side length of the okra was 6 inches. Huge. He split the okra into 5 equal triangles. So if this is my okra, I'm splitting it into these triangles, right? The height of the triangle is 4.1, so this height right here is 4.1. And the side lengths were 6. We already said that. What is the area of the okra? So the way we do this, we say how many sides does this shape have? So number of sides times the triangle that I made right down here. So 1/2 base, which is base times height. So this is number of sides is 5, because it's a pentagon, it has 5 sides, times 1/2, 6, times the height, which is 4.1. This becomes 5 times 3 times 4.1. That's 1/2 times 6. This is 15 times 4.1. And then 15 times 4.1. Well, 15 times 4 would be 60, plus 15 times 0.1 is 1.5. So this will be 61.5 inches squared. That's one big old okra. All right, and that's the whole thing. So math. I know this is long. So if you're looking at home, I appreciate your diligence. Classmates, do well on the test tomorrow.